In this video, we're going to do some examples of solving equations involving e. And generally, the strategy is to get the e raised to something involving x by itself. So here, in all these problems, we have x in the exponent. And for number 1, we have 50 times e to the 0.035x equals 200. Well, to get the e to the power by itself, let's divide both sides by 50. So dividing both sides by 50, you get e to the 0.035x equals 4. Now we want to get the exponent down. And to do that, we take the natural log of both sides. So if you take the natural log of both sides, natural log of e to the 0.035x equals the natural log of 4. Now, what's the natural log of e to the 0.035x? It's just 0.035x. In general, when you have the natural log of e to something, that's just equal to the thing. That's by definition of natural log. Because the natural log function is the inverse of the exponentiation function. So, the natural log of e to anything is just going to be that thing. Okay, that's the definition of the natural log function as the inverse of the function e to the x. So it's 0.035x equals the natural log of 4. And so now, what do? We divide both sides by 0.035. So x is natural log of 4 over 0.035. Now that's the exact answer. So if they asked for the exact answer, that's what you would put. But if they want you to give an approximation, you would put it into your calculator, and you will get that it's approximately 39.608 4. So I rounded it to 4 decimal places. Okay, so this is the exact answer. If they just ask you to solve for x, then you would put that. But they might ask you to round it. Okay, let's do number 2. Well, it's pretty much the same as the first one. It's just different numbers. So what's the first step? Divide both sides by 80. So e to the 0.045x is equal to 3. Then what's the next step? Natural log of both sides. And, okay, I'm just going to save some time by just putting natural log of this and the natural log of this. It's better to write it all over again to make the third line so that it's clearer what the steps are. But I'm just going to save time by doing this, and then I'm going to get 0.045x is equal to the natural log of 3. So therefore, x is the natural log of 3 over 0.045. That's the exact answer. But if you want an approximation, you can put it into your calculator and get that it's approximately 24.4136. Okay, number 3. Slightly different because we have an addition, but that's not too difficult. Let's subtract 3 on both sides. You get 2 e to the negative x is 6 minus 3. That's 3. And now we're back where we started. What's the next step? Divide both sides by 2. So if you divide both sides by 2, you get e to the negative x is 3 over 2. Okay, what's the next step? Take the natural log of both sides. The natural log of e to the minus x is the natural log of 3 over 2. How does the left side simplify? That's just negative x. So negative x is the natural log of 3 over 2, and now we can divide by -1. So x is negative natural log of 3 over 2. Okay, and I'll just leave that as the exact answer. Okay. Number 4. Well, number 4 is pretty much the same thing. So I'm going to subtract 7 on both sides. Well, there's actually two things you could do. One thing you could do is subtract 7 on both sides, but that'll give you a -3 in front of the e to the minus x, which is not a big deal. So let's subtract 7 on both sides. You get this. And then we divide both sides by -3. So e to the minus x is -5 over -3. Well, that is the same as e to the -x is equal to 5 over 3. And now we take the natural log of both sides and then divide by -1. So we get negative natural log of 5 over 3 as the exact answer. Alternatively, we could have added 3e to the x, or 3e to the minus x to both sides, and then subtracted 2. And that would give us 3e to the minus x equals 5. And then you would just do the same steps as before. Okay, let's do one more. So this time we have something a bit more complicated. 500 divided by, in parentheses, 1 plus 25e to the 0.3x equals 200. Well, the same principle for doing the other problems applies to this problem. We want to get the e to the 0.3x by itself. So hopefully you're familiar with how to do this. Let's get the denominator on the top. So let's multiply both sides by the denominator. That gives us 500 equals 200 times, I need parentheses, 1 plus 25 e to the 0.3x. Right? I need parentheses because I'm multiplying 200 by the whole thing. 1 plus 25 e to the 0.3x. Without parentheses, it would just be 200 times 1. And then adding 25 e to the 0.3x, and that's not what you want. Okay, what's the next step? We distribute. Actually, you don't. I was originally going to distribute the 200 across. Now, you can do that, but you actually don't have to do that. One thing you can do is just divide both sides by 200. So if you divide both sides by 200, the left-hand side is 5 over 2. The right-hand side simplifies to 1 plus 25 e to the 0.3x. Okay, I'm just going to write the expression with the x on the left-hand side because it's easier to work with. So 1 plus 25 e to the 0.3x is 5 over 2. And now what's the next step? This is basically the same as 3 and 4. You subtract 1, so you get 25 e to 0.3x equals 5 halves minus 1 is 5 over 2 minus 2 over 2, that's 3 over 2. Okay, now what's the next step? Divide both sides by 25. So e to the 0.3x is 3 over 2 times 1 over 25. Well, that's 3 over 50. Then what? The natural log of both sides. Natural log of e to the 0.3x is equal to the natural log of 3 over 50. And how does the left hand simplify? 0.3x. So 0.3 times x is the natural log of 3 over 50. And now the last step is to divide by 0.3. So you get natural log of 3 over 50 divided by 0.3. You might not like dividing by a decimal at the end, okay, but this is fine. If you want to rewrite it, you could rewrite 0.3 as 3 over 10, So this would be natural log of 3 over 50 over 3 over 10, and then that's the same as natural log of 3 over 50 times 10 over 3, because when you're dividing by a fraction, it's the same as multiplying by the reciprocal. And this is a way to write it as the same number, so that you just don't end up dividing by a decimal. Well, if you figure out what this number is, approximately, you end up getting that x is approximately negative 9.378. Now, is it okay that x is negative? Yes, it's okay that x is negative, right? X can be negative. And how do we know? Actually, by looking at this answer, I can already tell that before actually plugging into the calculator, I knew that I would get a negative number. How did I know that I would get a negative number? Because 3 over 50 is less than 1. And when you take the natural log of a number between 0 and 1, the result is going to be negative. So let's just recall. I mean, this isn't part of the problem. I'm just incorporating some facts just to review that if you have a number a between 0 and 1, and a is not 1, a is not 0, well, it would be undefined if a was 0. But if a is bigger than 0 and less than 1, then the natural log of a is negative. So that's how I knew I would get a negative answer. Okay, so those are some examples of how to solve problems involving e when you're trying to solve for x and x is in the exponent. In all these problems, x is in the exponent, and the general strategy is you want to take the natural log of both sides and then use the property that the natural log of e to anything is just the thing. And so if you look at this, that step is what allowed us to solve for x. Okay, thanks.